Hey, welcome back, AP Calc students. Today we're starting into a new chapter, but we're still doing derivative stuff. We're going to be doing derivative stuff for the whole first semester. So 4.1 is the chain rule. Now, the chain rule applies to compositions of functions, meaning functions with an inside and an outside. And we're going to see why in a second. So one way to think about it is the derivative of y with respect to x is equal to dy over du times du over dx. Now, they use this u thing here to say that we have a function or an expression in terms of x in there, but it's not just x. So it's kind of tricky, but once we kind of talk about it, then it's not too bad. I like this way, easier, better. It kind of makes more sense. So when we're doing the derivative of y with respect to x of an inside-outside function that we're going to chain rule, we just take the derivative outside, and then we do the derivative of the inside. Okay, and then the other way to think about it, and this is technical, but it is elegant because it's saying what it is, we take the derivative of the outside function. The inside function stays the same, and then we're going to do the derivative of the outside function. So whichever way works for you, and you can try them all and see which one works for you. They say the same thing, but whichever makes more sense is the one that I want you guys to use. All right, so let's kind of explain why we need to use the chain rule. So if we do our chain rule here, we really don't know how to do the derivative of that yet, right? We could kind of apply the power rule to the 2 and drop down the 2 and all that stuff, but we have all these things inside that's going to affect our derivative that we have nothing to do with right now. So let's go ahead and do this. We can do it by term for the first one. So again, this is the expanded form of the right side. So they're equal, they're equivalent. So we're going to go ahead and see how it turns out if we have the polynomial version versus the parentheses squared version using the chain rule. All right, so if we do this, drop down the 4 times 9 is 36, x to the third. And we're just applying power rule to each term. And then we have drop down the 2, that's 12x. And then the 1 derives out. Okay, using the chain rule, what we're doing here is notice the outside function is this square. So outside is that square. So our outside function, if we were to do composition, it would be f of x is x squared. Our g of x would be the inside, which is 3x squared plus 1. All right, so what the chain rule says is the derivative of y with respect to x is equal to dy du times du dx. So the derivative of this part, right, this whole thing, applying the power rule, would be, we drop down the 2 again in front, so 2, the inside stays the same, and then we'd subtract 1 from the power, right? But chain rule says we have to do this part of it, so we have to do the inside, the derivative of the inside, which is going to be, drop down the 2 here, that would be 6x, and then the 1 derives out, right? So that's going to be 0. Okay, so let's see if these two things come out the same. If we multiply them out, it's probably easier if we combine the 2 and the 6x first. So that's 12x. So when we distribute now, we get 12 times 3 is 36, x to the third, and then 12x times 1 is 12x. So notice that each side is the same. So again, the chain rule says to do derivative of outside with the inside the same, right? We didn't change the inside when we did the derivative here. And then times derivative of inside. Okay, let's take a look at another one. So this one we can't take it and make it into a polynomial by multiplying it out. That's impossible. This inside is staying inside. So this one we definitely have to chain rule. Like there's no getting around it. But it's not too bad, right? So our outside function is cosine, right? So we're going to do the derivative of cosine. So the derivative of cosine is negative sine. The inside's going to stay the same. But then we're going to do the derivative of the inside now. So times derivative of t squared 2t. The 1 derives out. So this is derivative of the outside. The inside is the same. And then derivative of the inside. Right, so this is our outside function, and then this is our inside function. Okay, and I guess the simplest form of this, if we wrote it in proper form, the 2t would come out in front. And then we should be good. This technically is okay, but usually we write it with the variables and stuff up front. Okay, last example here. It's asking us to differentiate the sine of x squared plus x. So notice the sine is the outside function, x squared plus x is the inside function, so we're going to take the derivative, right? We're going to take cosine. The inside is going to be the same, times the derivative of the inside, so we're going to have 2x plus 1. And I guess this would probably go in front, so it would be 2x plus 1 cosine x squared plus x. Alright, but that's it. So just really to get your feet wet, we're going to spend a couple of days on this chain rule stuff because it does get a little bit harder, but I want us to take some time because chain rule is one of those things that is all throughout calculus. So if you can understand chain rule and you know when to apply it and how to apply it, then that should set up your foundation for the rest of calculus. And then chain rule has a partner when we get into second semester and doing the integrals. So when we do u substitution, the chain rule is like the opposite of it. So if we can kind of get good with chain rule now, when we cover that idea later on in the year, then you will be, you'll have a head start. All right, good job today.